In this video, I'll be going through Chapter 9, the applications of straight line graphs. How do we arrange any non-linear equation into the form of y equals to mx plus c, which is a linear equation. Okay, so let's recap a bit. As what you have learned before, any straight line graph equation can be written in the form of y equals to mx plus c, whereby I know that m over here is the gradient of the line, and c represents your y-intercept, the y-axis intercept. Okay, so essentially what we want to do in this chapter is that I want to turn any equation, any non-linear equation, into this linear graph equation form, whereby I can rewrite the equation to become capital Y equals to mx plus c. Okay, and in this form over here, I can turn any non-linear equation into this form, whereby this can contain any functions such that I can arrange it in this similar format. And from here, I can obtain the gradient and y-intercept very easily. So let's see how one example how we can illustrate this. Let's look at this certain example over here. If I'm given this equation here, if I were to draw this graph y against x, I will definitely not get a straight line graph. So therefore, the purpose of this chapter is for us to turn any equations like this such that I can get a straight line graph when I draw it out. Okay, so let's apply our laws of logarithm in order to bring this power down, x. Okay, I want to eventually turn this into this form over here, y equals to mx plus c. So if I were to apply my laws of logarithm, I will get log y equals to log 2 times 5 power 3x. Okay, then if I apply my laws of logarithm, this will give me log y equals to log 2 plus log 5 power 3x. Further simplify, log y equals to log 2 plus this power can shift down 3x log 5. So therefore I can simply rearrange these terms over here to compare it to the y equals to mx plus c. I hope you can see that from here. My big Y is y. It is this log y over here. Okay, equals to my mx. In this case here, the m, I can actually see that if I were to rearrange this equation, so let me erase this thing. I rearrange it. Okay, I can rewrite this to become mx, which is 3 log 5, the whole thing times x, plus log 2. And I can see this is mx plus c. Okay, my x is simply this x over here, and this will give me the gradient and the y-intercept of this graph. So with that, I've arranged a non-linear equation into the form of y equals to mx plus c, whereby my new y now is log y, and my x is just x over here. Okay, and if I plot from here, in order to get a straight line graph, I will have to plot the graph of, instead of y, now it becomes log y as my y-axis against x. Okay, and this is how we can obtain a straight line equation from this non-linear equation. Okay, let's look at one last example. This is from 2024 O-Levels A-Math Paper 2 question 10. Okay, how do let's read this question here first. This question here says, I'm given this equation over here. Okay, explain how a straight line graph can be drawn from this equation. Okay, and you need to state very clearly which axis is which variable being plotted and how the values of a and b can be obtained. So let's write out this equation here. There are different ways to solve this question. Y equals to ax plus b over x. Okay, I want to convert this into the form of capital Y equals to mx plus c. How do I do that? So over here, there are different ways you can do it. Maybe I'll show you two possible ways you can convert this as such. Okay, first step, I want to make sure that all my x is contained within either your x or y. Okay, it should not be contained within your variables here. So what I can simply do is to multiply x to the whole equation. So over here, what I'll get is simply, let's call this option 1. Okay, multiply x throughout the whole equation. So therefore, if I multiply x, I'll get xy equals to ax squared plus b. Okay, this is one of the ways which we can convert this equation here. Then by comparison, if I were to compare this to y equals to mx plus c, I notice that since a and b are defined to be constants, now my new y will simply be xy, and my new x is simply x squared. Okay, and therefore I have a linear equation from here. Okay, and therefore, simply from here I can plot the graph of xy is my y-axis now against x squared. Okay, this is one possible way. Another possible way you can do this is simply to, I want to turn it into the form of y equals to mx plus c. That means that I want to get rid of, make sure that one of the terms here has no x, because both of these have x. Another way which you can do this is to divide by x throughout. So over here, the second possible way is to divide by x throughout. And if I were to do that, I will get y over x equals to a plus b over x squared. Okay, and if I were to rearrange my terms to get the form of y equals mx plus c, I will simply get over here y over x equals to b times 1 over x squared plus a. And if I were to compare to the form y equals to mx plus c, simply plot the graph of y over x against 1 over x squared. Okay, and from there we have obtained the linear equations. And also question here say explain how you can get the value of a and b. So from the first part, we know that a is over here. A is simply your gradient. A is gradient of the line, and b of line, and b is the, now it's not y-intercept but x-y-axis intercept. Okay, this is your new vertical axis, which is your xy axis. Okay, and likewise for the other part here, to find the value of a and b, I hope you can see that now. Over here, b is your gradient, a is your y over x intercept. So over here, a is your y over x intercept, and b now is your gradient of the line. Okay, so as you can see, there are two different ways to solve this question, depending on how you can visualize this to turn this in the form of y equals to mx plus c. Okay, and that will be the end of this video.